Hello, now can you hear me? Yeah, perfect. So we wait, as we wait here, in a few time we will get a live stream. Let me check for that, if we can get the view. And we are currently at T minus 18 minutes. We'll have we hope to have a on time launch at around 3:30 IST, or that could be around, that's like 10 AM UTC. So let's just check it, if the live is available. So we're waiting for Rocket Labs to get feed, so that they can feed us in. And here we are live. And okay, OP, thanks for the chat. Yeah, I can hear there one person. And let's see if we have Discord notifications gone. So as we wait, we'll soon start a mission briefing, and after our mission briefing is done, we shall switch to the feed of Rocket Labs. We also are thinking to cover tomorrow's launch. That's 4:10 a.m. IST, or I think that's 3. I think 3 in the evening. And so that's we are expecting. And we are also expecting to cover a launch on Monday of the Delta rocket. So if you are on all social medias, the links are in the description. And let's see. Okay, so as we wait for Rocket Labs, we shall go through mission briefing. So this is the one of the launches, and here we have our Rocket Labs audio, feed is coming in. We shall wait for a few seconds. So the Rocket Labs, this year's, I think it's the third launch, one of the third launches, and it's a Rocket Lab running out of toes. The mission name is running out of toes. So yeah, we had an issue out there reconnecting, and it takes time. So yeah, as I was saying, BlackSky is a imaging satellite. BlackSky is currently working on launching today 2 satellites out of their 16 satellite constellation that are going to make up, and they are they are trying to image the Earth and analyze and gather data, so that they can predict how COVID-19 has affected business, and we are recovering from COVID-19 on the basis of economy. And its major is to also get data on international cargo. So yeah, that's one of data. And I think we are facing internet issues. We'll soon be switching to better internet, but for now we'll have to wait. So as we wait, so as you can see, we are waiting here for Rocket Labs to start their stream up and their webcast. We are green for we have a 10-day, I think, no, it's a 13-day launch window, 14 to 13-day launch window. And the launch site is Launch Complex 1 Pad A at Māhia Peninsula, New Zealand. So people out there watching us in New Zealand can see this launch. So as I was saying, the inclination of the payload will be 50 degrees, and the customer is BlackSky, and this launch was booked by Spaceflight Inc. So we are targeting on time launch at 10 UTC. So what's the mission overview? We have this Okay, yeah. So we are now, as I said, we'll have a recovery today of this booster. This is a data analysis. They are basically testing today how to reuse rockets. They have been testing from a while for their launches. This is the first phase of a reusability test where they will be splashing down boosters into the ocean, and this is the second time they'll do a splashdown. So at around 2 + 2 minutes, we'll have the rockets. The first stage have reach its apogee, and then we'll have a deorbit burn, something like that, and after which we have a good heat shield that will protect the engines, the Rutherford engines, the 9 Rutherford engines of the first stage, and we'll have a we'll reposition it at 180 degrees for the Rutherford engines to splash down, to face the earth, and then at around when we get subsonic, or we are not most faster than Mach 2, we'll have the one small parachute deploy, after which we'll have a bigger parachute deploy, and finally there's a splashdown, and we'll have the Orca, or the ocean recovery capture apparatus. That's a ship that will recover the booster to land, and this is the first phase. After we have the third one happening, we'll move into the second phase. They'll move into the second phase of testing reusability by catching the boosters mid-air. So as we wait for another 10 minutes for the rocket launch, the weather is good and go for launch, and yeah, I think they are now starting their stream. So we'll switch on to the webcast, I think, and after around T+8 minutes, we'll have a big coast phase where I'll again do a mission briefing and open the chat for Q&A. So let's go.
Hello and welcome to the launch broadcast for Rocket Lab's 20th Electron mission, running out of tows. Electron is fueled and ready for liftoff from Rocket Lab's Pad A at Launch Complex 1 in Māhia on New Zealand's east coast. My name is Pitara, otherwise known as Orca to our recovery vessel. This hydraulic cradle is essentially a recovery optimized strongback to help safely bring Electron aboard. But maybe most excitingly for this mission is the fact that we'll be flying previously used components for the very first time. Electron returned in such good condition during the return to sender mission that we're reusing its propellant press system on this one. Now, with the recovery...
Yeah, sorry for that. I mean, we are disconnected. So we are still trying for the feed to come back.
Around Electron will heat up.
Cisco. Avionics.
Avionics is go.
GNC.
So yeah, we are
GNC is
having
go.
feedback, and
Beacon is go.
we have
G1.
the go no go poll
GC.
coming up.
GC is go.
So the go no go poll
PLS.
is a
PLS is go.
RSO.
poll that the mission director conducts for all the systems to check that whether the rocket is go, but all rocket systems are go for launch, and we are currently in that phase. Over to their audios.
Executive is go.
Go no go sequence complete. We are at 11 minutes, 12 seconds and counting. We're go for terminal count start at T-minus 10 minutes. From this point on, the 3-word hold procedure is in effect.
There you have it. That's confirmation from Mission Control that all systems are go and will be proceeding with the remainder of the count. Liftoff remains scheduled for 10:08 p.m. New Zealand local time or 10:08 a.m. UTC. Now to this launch's primary mission objective. Running out of tows is our third mission for 2021 and the first of several dedicated launches this year for BlackSky, which provides geospatial intelligence and global monitoring services through their low Earth orbit constellation. Electron will be launching 2 of these satellites at a 50-degree inclination from Launch Complex 1 and deploying them to a 430-kilometre orbit. Once in space, these Gen 2 satellites will mean BlackSky can better deliver insights to decision makers, responding to disasters or tracking economic activity across the globe. Out of tows will be our 4th mission for BlackSky through launch services provider Spaceflight Inc. The first was Make It Rain in June 2019, followed with our second 2 months later on our Look Ma No Hands mission. The third BlackSky launch on Electron was this year on our They Go Up So Fast rideshare mission in March. Tonight's mission is part of an overall deal to deploy 9 BlackSky satellites across 5 Electron missions this year that delivers them the rapid launch capability they need to expand their constellation quickly.
So we had a go no go poll, and we have found out that all systems are go for launch. So currently we are expecting to at
For the team here
T-2.
at Rocket Lab, this mission also marks a couple of fantastic achievements because tonight's launch will be the 20th time Electron leaves the pad, powered by our 200th Rutherford engine. It's incredible to think that we've built, tested and fired 200 of our unique 3D printed electric pump-fed engines. Rutherford is the world's first 3D printed orbital rocket engine, a unique design that went against the grain of traditional rocket propulsion systems when we first introduced the idea. Rutherford also made space travel electric by replacing the traditional gas generator cycle with electric pumps powered by lithium polymer batteries. This mission is one for the history books, so we sat down with some of the team who helped make it happen to talk through their experiences of our first 20 Electron launches.
What we have here is just a completely
defiant group of people who really want to execute and see things succeed.
It never gets old, whether it's the first flight to orbit or the 20th, whether it's our first customer or our 200th. We're learning something every single time.
I mean, I'd been here for 5 months. We didn't know if it was going to work.
It's mainly getting the customer's payload into space. It's game time.
Launch day is space Super Bowl, right?
I don't even remember breathing, but it was worth it. It's a feeling you just can't describe. You just have to really be there.
I'm much more interested in the payload these days. So for the first few flights, it was all about the rocket. Whereas now, I get to know a little bit more about who we're launching.
Launch day is way harder than I thought it was going to be. I thought by the time you get to 20 launches or some number, it would just be like, making coffee. Everybody's just so invested in each launch that there's always so much energy around each launch.
Hearing that our first light satellites come alive and things like that it's a totally different feeling than just we've launched this rocket and that's been awesome.
20 missions is a huge achievement, and it's been incredibly exciting, but I'm even more pumped for the next 20.
So I'm super stoked about recovery from the quality engineering perspective.
I like the fact that you get to launch the next. It means that you've done your job right.
I mean, fundamentally, we must have a really good design. The fact that we can launch this many rockets, Electron's a good product.
Rocket Lab's secret sauce is its engineers' dedication to rapid development.
We would not have been successful had it been a different group of people.
Oh, I think I'll be in for another 20 flights. Congratulations to every single Rocket Labber who got us to the pad today and helped us reach these milestones. A check-in on how we're tracking to liftoff. The team are working no issues with the launch vehicle. Electron's payload remains healthy and the weather is looking clear for an on-time launch. We're approaching a critical juncture in the lead up to launch now, the switch to the countdown auto sequence. In T-minus 2 minutes, the autonomous flight computers on Electron will take over the count. At around T-minus 1 minute 30 seconds, we should hear the call that LOX loading is complete on Electron. And then shortly after that, we can expect confirmation that the launch vehicle's first and second stages are pressurized for launch, followed by the 10-second countdown to liftoff with engine ignition at T-minus 3 seconds. Let's hand over now to Mission Control and listen in for those calls.
We are go for our sequence start at T-minus 2 minutes.
HV blips nominal.
Confirm LDs go for launch.
Hold.
Got to hold. Recycling T-minus 12 minutes. All stations stand by for recycle to T-minus 12 minutes. GC confirm a launch inhibit mode.
Still in prime mode. Confirmed.
Okay, we're in inhibit at this time.
So you heard it there from Mission Control in Auckland. Right now, Electron has entered a hold while our operators work on establishing a new T0 time. We'll continue to broadcast while we wait for an update from the team. In the event of an extended hold, we'll provide an update via our social media channels. Thanks for watching. We'll be back with you soon.
So as we heard about this, we have some issues going on, and we are now trying to get up a new launch time for the T0 time, because there's some issue in the rocket. So as we move on, we have new viewers. So let's start from basics and a little bit of mission briefing. So this is a 14-day launch window where Electron can launch from, that opens at May 15th May 10 UTC, And this launch site is at Launch Complex Pad 1A. Pad 1A in Māhia Peninsula, that's in New Zealand. The payload is a BlackSky satellite. So it's a BlackSky is a company that's providing worldwide. Its main mission is to create a constellation of some few satellites, like 16 or so, that can monitor the world with imaging. And recently, the port blast that had happened last year, their AI could easily detect while humans take time for the image to process, and then they take actions, whereas these satellites have AI inbuilt which alarms the company immediately if there's any issues where they're imaging it. These satellites are also tracking economic progress after the COVID-19 has declined in some areas, and they're also tracking international cargo. So this is one of the fourth launches and third launch this year of the BlackSky. Fourth launch for the BlackSky that Rocket Lab is doing, and this is third launch for Rocket Labs this year. We are also expecting a new launch time. We have gone past the expected launch time. So the payload will be in orbit of 430 kilometers above Earth. These are 2 satellites out of the 16 satellites, and its inclination will be 50 degrees, which can be altered from 45 to 50 degrees. This launch was provided by Spaceflight Inc. That booked it from Rocket Labs. So we'll have a booster recovery, not a drone ship recovery, but it's an ocean splashdown, and it's a part of technological demonstration and data analysis that Rocket Lab is currently working on to decide upon a reusability technique. In their second phase of testing, they'll also do mid-air catching of the Electron booster, but this one is basically the splashdown of the booster, and then the ocean recovery vessel shall recover it. We are currently waiting for a new launch time, so that clocks have been paused. Mine is at T-130, whereas they have a 2:30. It was just an error glitch that we couldn't see where its clock is working or not. So we are currently facing some issues in the rocket. As far the rocket is concerned, the overall length of its rocket is 18 meters, and it's just 1/4 of what we see of a Falcon 9 rocket. So it has 2 stages plus a kick stage. Now, a kick stage is something we haven't seen for a while with these rocket launches. So kick stage is nothing but it's a part of the rocket that you could call upper stage or third stage. This third stage helps the rocket
due to upper level winds and have recycled the clock to T-12 minutes. We'll stay on the live view of Electron on the pad while the team assesses those wind levels, and we'll come back to you with a new T0 as soon as it's confirmed.
So as you heard, we are now on T-12. So yeah, as I was saying, the kick stage helps better deployment of satellites. So basically, if there's a second stage only, the second stage deploys the payload, and after some maneuvers and all, the satellite has to maneuver and do some stuff to get into its original orbit. This takes time for the companies that have these satellites to get data from, means a longer time period for the satellites to basically work. But with the kick stage enables it to exactly get into the orbit, the particular functional orbit of the satellite. We have the propellant as LOX and kerosene, and the material is of carbon fiber composite or monocrome. And we also have fairings on the upper side of it. The Rutherford engines are 3D printed engines and are one of its art of technology 3D printed engines. It's a new technology. It was basically invented by Rocket Labs itself. So they 3D print the Rutherford engine. And yeah, so the pump is also not gas feed, but this is a new milestone rocket industry or the aerospace industry has achieved, is of getting electric rockets, not fully means it's still be powered on fuel, but the rocket pumps that is basically what the rocket engine pump is, something that pumps in the fuel from the header tanks to into the engine. So this is now powered by batteries, lithium polymer batteries, and not some kind of gas. And this is a new milestone for us. So the payload is today of 60 kgs, whereas the payload Rocket Labs Electron can take is around 200 kgs. Fairing diameter is 1.2 meters and height is 2.5 meters. Now we have pneumatic unlocking and springs for the fairing separation. The fairings won't be recovered like the one SpaceX does, but we do have booster recovery. We have one Rutherford vacuum engine in the upper stage, the second stage, and 9 Rutherford sea level engines in the first stage. These stages help propel to the parking orbit, whereas the Curie engine in the upper stage is what helps it to get into the working orbit. So the Curie engine is also a 3D printed engine, so that's like most of it is 3D printed. And we have an interstage with pneumatic pushers to separate. We will at around T-4 hours we had the road closure. At T-4 hours we also had the Electron being raised vertical, and we had fueling had begun. And at T-2 hours we had the LOX loading started, and at T-2:30, T-2 hours 30 minutes, we had all the launch pad was clear, and at T-30 minutes we had safety zones activated for designated airspace, so there is no aeroplanes or any other airspace activity in that area. At T-18 minutes we had the go no go pole, and we shall now put the clocks back to 12 minutes. Yeah, I think that's and so we'll have a launch auto sequence at T-2 minutes. We're basically waiting for this to happen soon, but due to winds in the aerospace above, we are facing some delays, so we are waiting for the winds to clear out, to subdue, and then we can go for launch. Then at T-2 seconds the Rutherford engine will ignite, and then we'll have a lift off at T-00. Till now we have the go no go pole, and we had the BlackSky company brief. So more about payload I'll now tell you as I get information. Yeah, so the BlackSky is now monitoring some of the major insights for early responders, that they have AI inbuilt in their satellites for faster data analysis, like the one that happened on the Beirut port explosion. The Spectra AI automatically tasked BlackSky's global constellation to image the port for damage assessment and delivering critical insight for early responders. We are also tracking economic activities, and they're also tracking COVID-19 in a changing world. Now we'll also see what recovery missions are they going through today. So the Electron's first or the Rutherford stage will first will separate, then after its engine have completely shut down, it will around coast till it reaches the apogee. Then during the coast we'll have the first stage reorient itself to 180 degrees. That's an ideal angle for re-entry. Then it will enter the Earth's atmosphere, where it will face around 2400 degrees Celsius of Fahrenheit of the heat. Yeah, 2400 degrees, and it will be traveling at 8 times of the speed of sound, of Mach 8. So after it reaches max q, before Electron reaches the point of its descent, when the force against are at peak, also known as max q, the first stage will reposition engines first, so that it doesn't get much damaged. After it deaccelerates itself to below Mach 2, we'll have a drag parachute that will increase the drag and stabilize the stage for so the velocity comes down. We'll also have a larger parachute open after it's just few kilometers from the water, and then it will land in its ocean, that's the Pacific Ocean near New Zealand, where the orca or the ocean recovery capture apparatus will pull it back to the Rocket Labs factory, and where it will be then inspected. Now we shall wait for some minutes, so be right back. So if you're still watching, we are on Instagram, we are also on our Facebook page. We have a Facebook page. All links are in the live chat as well as in the description, and there's a lot of information about this mission too. You can also follow me on Instagram, we follow our Facebook page. Don't forget to like that page. We are also on Twitter. You can follow us there. And I think so we have some briefing.
As you can see, we're currently in a hold due to upper level winds. Stick with us as we establish a new T0 time. We'll let you know as soon as that happens. But today's window remains open until 12:05 a.m. New Zealand time or 12:05 UTC.
Yeah, so as I was saying, we are also on Buy Me a Coffee. We also have a website, We also have a website, and we're also on Discord, so do join my server and subscribe to this channel if you think it's worth consider subscribing, and like this video. So we are still waiting. We are at T-12 minutes, and we'll be getting a new T0 time. Thank you. The launch window is still open till 12:05 UTC.
All stations LD on mission. We're currently holding the clock at T-minus 12 minutes while the GNC team work through further verification of upper air winds and running some worst case data. Expected time to pick up the count is no earlier than 111139 UTC. That's for target T0. I'll report back in about 10 to 15 minutes when we hear back from GNC.
Hello again. As you can see at the bottom right of your screen, we are currently holding at T-minus 12 minutes. The team is assessing upper level winds to determine a new T0 for today's liftoff. All other systems remain go though for launch, so it's just a waiting game for those upper level winds. We'll update you as soon as we have a new T0.
Well, if you just tuned in, guys, we are currently at a halt in the rocket launch. So I had a mission briefing twice, and we are currently halted due to some winds around the launch pad. Whereas this channel is all about space. We also make videos on electronics projects and PCBs and stuff related to tech. So do check out my channel for these videos. By the time we are halted, we'll also get as soon as we get the updates, we'll be sharing you in the lower third below, and also in the chat. Well, if you're still watching, consider subscribing, like the stream, and share it with your friends so that they can have this experience of watching the rocket launch with me. And I'll be also sharing some facts about this launch and also briefing you in the coast phase. The company's webcast will be a little more technical, but as I explained, it will be a very I'll be explaining it in a simplified way, which you will be enjoying as we get into the launch and post-launch events. If you're in New Zealand, you'll be able to view this at around Māhia Peninsula in your country. It's gonna launch from there, and it will be the second stage will cut off in around the Pacific Ocean. So be sure you check out your skies for a good rocket launch. It's currently night out there, so you will be able to see good flames and flares in the sky. Rocket Labs is a launch rocket manufacturing and aerospace company that is basically more specialized in launching CubeSat satellites that are very small in size, not like SpaceX, which launches a very heavy payloads. Rocket Labs Rocket Labs' main goal is to send CubeSat satellites as a main payload and not a rideshare. So basically, in the a few time, like in the past, CubeSats or small satellites had to wait for a rideshare on a bigger payload. For suppose if the rocket is going is launching and there's a little more space for payload to fit, these small satellites could be fit there. But with the help of Rocket Labs specially customizes the payloads, and with its third stage, it also helps the satellite manufacturers and satellite companies to directly get into operation after their satellite has been launched. The launches before this didn't support like this. Even SpaceX does not do this on any other company or organization launching rockets does not follow this pattern. The third stage also adds to the mass, which for bigger satellites isn't very much possible, but for CubeSats it's possible, and they put it into the working orbit, the functional orbit, and not a parking or deploying orbit, which is great for such companies using small satellites and get their satellite directly into operation. The overall length of this Electron rocket is just 18 meters, and it's 1/4 of what a Falcon 9 Block 5 would look like. So thus it can also support only a small payload, but its main goal is to get smaller payloads into orbit, so that they do not have to wait for rideshares and get directly. Their launch cost is also very less compared to a Falcon 9 Block 5. The Electron rocket is powered by 9 Rutherford sea level engines on its first stage, which then separates from the second and the third and the upper stage, which are combined. The second stage is powered by one Rutherford vacuum engine, which accelerates into orbit, a parking or deploy orbit, where the fairings deploy and burn up in the atmosphere. The first stage is currently being tested to be recovered, and they are in the first stage of testing, where they are seeing to splash down the orbital booster, whereas in the second stage of testing they'll catch the booster in mid-air, the mid-air catching will be done by a helicopter which toggles itself to the booster's parachutes, and that will be a very exciting thing to see. Whereas SpaceX is basically using the drone ship. These are the only two companies around world that are reusing rockets, whereas SpaceX is now in a phase where they frequently reuse rockets, and they had achieved a milestone earlier of reusing its booster for a 10th time with a 10th successful recovery. Rocket Labs is currently testing its boosters for reusability, and after the second stage completes its burns, the third stage or the kick stage separates, and it's propelled by its Curie engine, which then gets it into the deploying orbit, which is good for which then can release satellites into the deploying orbit. After which a Curie engine, the Curie or the third stage, does a little bit of maneuvers and firing, so that it comes into a lower orbit and where it can do some of its technological demonstrations. As of talking of their reusability of their last booster, some of its parts have been reused into this rocket. This rocket is made up of carbon composite material, carbon fiber composite, and is propelled by LOX or liquid oxygen and kerosene. And also given big update, India's launch of the GSAT-1 satellite, that's the geostationary imaging satellite, has been delayed further. This can be seen as a big sacrifice by the ISRO, but it's after you'll hear the reason, it will be a proud moment for the nation. So currently India is facing a big pandemic, a big second wave of the pandemic, and in which we are facing an oxygen shortage. All rockets around the world, most rockets are propelled by liquid oxygen.
Another quick update from Rocket Lab Mission Control. We are still sitting tight on the pad waiting for upper level winds to fall within bounds for launch. The clock is currently held at T-minus 12 minutes, so while we wait for that new T0, let's take a look back at our first recovery mission back in November last year.
Congratulations to the recovery team. That team has pulled off a miracle with re-entry of Electron in the first ever attempt. So in the return to centre mission, we set out to achieve a number of things, and all of those things increase in complexity and risk. The first thing was to reorientate the stage and get it in the right angle of attack. We've done that a couple of times before, so that was obviously very successful. And the next big thing was to start deploying the parachute systems. And we ticked off each one of those milestones one by one in a very successful manner, and then ultimately splashed down the stage at a really low velocity into the ocean in wonderful condition. So that was kind of like the giant. And in fact, there's even components on that stage that we intend to refly in an upcoming mission. So the thing I'm most excited about reusable Electron is two things. One, we can offer many more flight opportunities because we don't have to build so many rockets. And right now, we're pushing one Electron rocket off the line every 30 days. If we can reuse Electron, then we can create a lot more flight opportunities. Equally well, if we can reuse Electron and get them back in the condition that we're hoping now, it completely changes the economics of the small launch industry, which I think for our customers is really exciting. Electron is a reusable rocket. It's a great milestone, and I guess something a few years ago that I didn't even think was possible, so that makes it even more sweet.
Yes, as we're seeing, the liquid oxygen is the most prominent propellant around world for rocket industry, and the propellant, the ISRO's propellant in the propellant center donated a lot metric tons of liquid oxygen to the hospitals in and around in India. So that's a great thing, and we'll be updating you if there's any launch updates, is there any scrub or not, and we'll be giving facts about this mission and other missions that have been recently happening in space flight. So stay tuned.
Thank you for tuning in to today's launch broadcast. As you can see, the clock has resumed and we are currently at T-minus 17 minutes and counting. Electron might be the rocket on the pad today, but recently we announced plans to build its much larger sibling, Neutron. While we wait for a new T0, let's take a look back at that announcement.
When we say we're going to do something at Rocket Lab, we do it. Not just once, but over and over again. The Electron rocket defined a number of industry firsts. First carbon fibre rocket to orbit, in fact. Somebody told me once that was going to be impossible. And it's reusable. But then there's the engines. The Rutherford rocket engine, the very first 3D printed rocket engine ever to go into orbit. And in fact also the very first electric pump cycle rocket engine ever produced. And of course we didn't stop at rockets. We started building satellites too. Satellites to go to low Earth orbit, satellites to the Moon, to Mars and Venus and beyond. And there's a lot more to come. But first, I've got to take care of some business here. There's a lot of things at Rocket Lab that we said we were going to do that we've done. And a few things at Rocket Lab that we said we would never do, which we have also done. So I really think with this project, it's about time. This hat is not tasty. But there's some things we said we would never do. But we're going to build a big rocket. It's called Neutron, and behind me is just the fairing. This is a purpose-built mega constellation building machine for all the mega constellations of today and of tomorrow. It's an 8-ton class launch vehicle, and of course, it's reusable. But one thing that's probably more exciting and most unusual for Rocket Lab is that this vehicle is capable of human spaceflight.
We're all incredibly excited to bring Neutron to the pad, and we will have updates on its progress coming soon, we promise.
So we have got a great news there. The clock is started ticking back. So yeah, we are at 14:20, T-minus 14:20, and that's great news. We just had the Neutron's briefing, or the what they are building, the Neutron rocket. So as we wait, we had the go-no-go poll already at around T-minus 18, or from now it's like around 30 to 35 minutes ago. So we seem to now have a nominal countdown, and we do not hope so that any other problem is now coming, because we want it to go today. I mean, it's my also first Rocket Labs live webcast that I am also watching, and even I am broadcasting it. It's my first too, and I also want to see how they splash down their rocket. So more briefings coming up. And yeah, congratulations to China. I mean, they landed their landing module on the Martian surface, and it's like one of the three nations to do that, and they did it in the first attempt. Like we beat them in, like India beat them in sending the first orbiter or some spacecraft to Mars in its first attempt, but they beat us by sending sending the first lander in its first attempt.
We're approaching T-minus 12 minutes in the count, and soon our operators will conduct another go-no-go poll after the hold. Let's listen into mission control and check how we're tracking for our second attempt of the day.
So yeah, as I was saying, China beat us, and I think it's now started a space race. I think like every every third day you can see something coming up, like one day there's this launch and that launch, and now Starship is ready, China is copying Starship. Like, I think another space race will start, and this time it's gonna go for long. I think 2050, not the rather that ended soon by sending people to moon, but this will end up like colonizing Mars or maybe another planet or maybe another moon, some moon of.
All stations LD on mission cord, proceeding with the go no go poll for
Maybe
launch.
the
Stage.
Saturn's or Jupiter's
Stages
moon.
go.
So now
Avionics.
we have a
Sky.
go no go poll.
GNC.
GNC is go.
Beacon.
Econ is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
Mission management.
Mission management's go.
Recovery.
Recovery is go.
LD sub.
LD sub go.
Executive.
Exec is go.
Go no go sequence complete. We're at T minus 11 minutes, 21 seconds and counting. We'll go for terminal count to T minus 10 minutes. From this point on, the 3-word hold procedure is in effect.
So as you heard it, we had another go no go poll, and it's like
LDGC.
Proceed with sequence 50 pad terminal checks.
Copy proceeding with sequence 50 pad terminal check.
so yeah. So we completed the go no go poll, and it was another go no go poll, and they're re-attempting to launch it. Hope this time nothing comes in, and yeah. So I think that there's a space race coming for us, and we will get a full advantage. Last time it was just to prove.
Avionics LD mission.
Go ahead.
Proceed with avionics terminal checks. Sequence 51.
Proceeding with sequence 51.
So last time we had just a demonstration of people putting people on moon.
LDGC on
This
mission
will
board.
be a
Go.
civilization.
Stage
So
1
we
ignited pressures verified.
will
hydraulic
hear
pressures
from
verified.
the mission
S1
controller
preview
right
open.
now, and
Pad
I'll
terminal checks
brief
complete.
you about this,
Copy
and
that.
we'll open the chat for Q&A after launch, and maybe some post-launch events when we are in coast phase.
Stage LD mission.
LD stage.
Proceed with sequence 52. Stage terminal checks.
Copy.
GC LD mission.
LDGC.
Proceed with pad ready for launch. Sequence 53.
Copy proceeding with sequence 53. Expander switch to high power for flight. Stage 1 and Stage 2 high voltage batteries ready for flight.
All engine blips are nominal. All engines are ready. The stage terminal checks are complete.
Copy that stage. Avionics LD mission.
Go ahead.
Proceed with sequence 54, AFDS enable for flight.
Proceeding sequence 54. AFTS is green and enabled for flight.
Copy.
Hold on mechanisms armed, strong back retracted for flight. LD GCI mission.
Go.
BCS disabled, pad auto sequence is armed, pad ready for launch.
Copy. Recovery LD mission.
Go ahead.
Proceed. Confirm recovery as goes a green.
Affirmative.
And monitor them from the airborne.
Affirmative.
Avionics LD mission.
Go ahead.
Proceed with sequence 55. Enable recovery systems for flight.
Proceeding with sequence 55.
We are at T-minus 4 minutes and 42 seconds and counting. The strong back has been retracted for flight and those upper level winds are currently playing ball. From here on out, we'll listen into mission control as they proceed to T0.
All stations and missions, LD. From this point on, there should be no red flags in the critical LCCs.
HVB reports.
Copy that, avionics. Beacon LD mission.
LD Beacon.
Confirm flight computer as goes a green.
All as goes green.
Lock auto sequence and confirm.
Auto sequence locked.
All stations ready to go for auto sequence start at T-minus 2 minutes. At this time, LDs go for launch.
These are on internal power. Confirm all stage power is disabled. Vehicle is on internal power.
So yeah, we are just around 1 minute 30 seconds, 1 minute 40 seconds away from the launch. And if you are on social media, all social media links in the description.
Upload complete, system
We'll find a lot of information on this rocket launch, and also my social media links. We also have a website, and we also have a Discord server. There's a lot of information and updates coming up there too. And we have Insta, we have Facebook page, and we also have a Twitter. So yeah, do join there and do follow us. We are currently waiting for T minus 2 seconds, and yeah, I have the launch progress sheet. So we had a go no go poll again. This is the second attempt to launch. The first attempt was scrubbed after winds. We had reached till go no go poll. This time we have the launch auto sequence has begun, and they have the all the audio coming in.
Stage 1 and Stage 2 tanks are pressed.
Yeah, so this is all the auto sequence that is starting, and all the checks are now coming in for what has started and what is not. And we are now waiting at T minus 002. Psycho Mantis Afia. This is the Electron rocket.
T minus 20 and counting.
This is the Electron rocket, and yeah. So we are T minus 2 minutes.
T minus 10, 9,
8,
7,
6,
6
5, 4,
3, 2.
Lift off! Yeah, go! Just pleasing. That's so pleasing.
At T plus 30 seconds into the mission, Electron is well on its way to space after its 20th liftoff from the pad at Rocket Lab Launch Complex 1. We had a great view from the tracking cameras of the power of those Rutherford engines, with Electron clearing past 700, it's clearing well on its way to space right now.
Yeah.
And very soon Electron will approach max Q, or maximum
waiting for max
aerodynamic
Q, and
pressure.
that's so good.
And this is the moment when the forces against the launch vehicle are at their peak during ascent. So let's listen in for the call that Electron has cleared that gate.
Ship run 1.
Approaching max Q.
HVP discharge nominal.
Max Q cleared.
Trim sheet run 2.
There's the call out. Electron has successfully passed through max Q, with propulsion continuing nominally. In about a minute, we'll be coming up to 3 events that happen back to back during flight. First is main engine cutoff, or MECO. This is when the 9 Rutherford engines on Electron's booster throttle down before shutting off completely to slow the rocket down before the second event. That's when the first stage separates from the rest of Electron as it continues with the third event, ignition of the sole Rutherford engine that powers Electron and the satellites to orbit. With that stage separation, Electron's booster begins its journey back to Earth, and so will begin our second Electron recovery attempt. We'll hopefully have a live camera feed on that first stage to watch that descent take place. But before we get ahead of ourselves, let's wait for the call out for those 3 events.
Stage 1 propulsion is nominal.
Yeah, so as we have...
and MECO confirmed.
Okay, MECO confirmed. And we are staging, so the first stage has...
Staged ignition.
We also had the fairing separation.
Recovery, proceed with sequence 59, stage 1 recovery operations.
We are also waiting for fairing
As
separation.
you've seen, we've had a successful MECO and stage separation. No, there's been no ignition, sorry, but on your screen we'll keep that view and see what we can come back to you with soon.
So yeah, we had a on-time liftoff. We had at around t plus 1 minute, some 30 seconds, we had the max Q, and we then had the main engine cut off, the 9 Rutherford sea level engines cut off, and then we had the stage separation. Next, I think we'll have fairing separation, or it has happened. The calls merged, so we couldn't hear that. Next, we'll have the second engine start, and so the best part of this rocket is fun. It's the engines are 3D printed, so like not the other engines that are made up of metals and all other composite material. It's 3D printed. And next, it's the feeding pump, or the pump that feeds in the propellant to the engine, is made up of is propelled, or it's ignited. What do you call that? I mean,
Okay, so it looks like we've had a loss of telemetry. We'll come back to you with more information as soon as we have it.
yeah, so the pump is then powered by not gas from the propellants, but it is powered by lithium polymer batteries, and that's a big milestone in the in rocket and aerospace industries. These are two big milestones: 3D printed engines and electric run gas. Pumps, electric fed pumps. So that's a great milestone. Next up, I think we have lost some signals, but we will confirm whether the second stage has ignited. We then will have battery jettison, or hot swapping, where the batteries fall out. So yeah, as I said, the pump is run by the batteries, lithium polymer batteries. So there are 13 on the first stage, which are just a few minutes ago separated. This second engine pump is also run by lithium polymer batteries. So two of them will just separate and burn into the atmosphere. This reduces the load on the reduces the weight on the second stage, which can help in further propulsion, or it can go more far than it goes if it carries those batteries. So that will come up soon. We had a fairing separation, but currently we have no telemetry signal. We are trying to establish it again, so stay tuned.
An update from Rocket Lab Mission Control. We are experiencing a telemetry issue with today's mission, and therefore do not have live views of the vehicle to bring you at this time. So we're going to end today's webcast and bring you updates via our social media channels. Thank you for tuning in to today's mission. We'll see you back here soon.
So yeah, that's not good. I mean, we haven't still oh, what's that sound right there? Can you guys hear it? Yeah, I think I need to stop there. Okay, that's in my think I'll just wait for a minute. Yeah, so as we can see, we don't have telemetry data caused due to bad weathers and other things, so we couldn't get further webcasts. They couldn't get any further webcast, any live view, so they have now stopped the webcast. We have still much events which will be coming up on their social media and mine too. So what's next was that we would have seen the SECO, I mean the second engine cutoff after the second engine restarted, and yeah, and we would have many other moments like the Electron entering, parachute, splash down, recovery, and we would have the payload deployment isn't available because the kick stage is too small and it's very small to fit a camera, because its main motive is to carry payload and no extra weight, and we could have seen it till there, but I think there was a lot of telemetry problems today. Even in the launch we couldn't do it in the first attempt, and there's one person, what is the motive for launching Psychomindus FF. So yeah, today's launch payload was a BlackSky's satellite. So BlackSky is a company that's working on putting imaging satellites into orbit. So if you remember the Burette explosion that had happened, yeah, so their satellites had their AI on their satellite has detected it early, and we had so this is a big constellation, like 16 or 17 satellites are going up there. So this is the fourth launch that Rocket Labs conducted for them. This was booked through Spaceflight Inc. And this was the third launch for Rocket Labs this year. So currently they are working on data which has data like COVID-19, how economy is recovering from COVID-19, cargo and other things. So basically the motive was today, and it had also technology demonstration of recovering the booster through a splashdown, and the kick stage is a big milestone. I mean, the Curie engine, the 3D printed engines is a big motive. There's a lot. This was the main motive. The payload was to get imaging satellites directly into orbit, and some people are saying that's waste of money. I don't think so. Like satellites are not waste of money. They are helpful. Yeah, rocket launches do fail, but failure is an option, right? We learn from failures, but yeah, the main motive was to put imaging satellites into orbit, the imaging satellites of BlackSky. So after this I'll open the chat for Q&A. Any questions related to the this stream, like this rocket launch, can be asked in the chat. We'll wait for some time, like around 4 to 5 minutes. If there's no question, we'll see a goodbye. Any questions? We'll wait. Okay, I think we have some issues with our live chat. We'll soon get into the issues, but for now we are ending our webcast too. Thanks for tuning in.